Hello everyone, welcome to our class. Today, let's talk about a bit operators, very special operators in C languages. So you will find that they are more useful than you thought before. So let's take a look at a bit operator. Actually, we will talk about 6-bit operator today. The first one is a bitwise AND. Second one is bitwise OR. You probably has a questions why they use and to represent and, not just and, because they already set the and operator as a bitwise operators. So in Java, if you remember, you also use and. In C, it's used as and two if you want to combine two conditions together in your if statement. So why they don't use and? Because and is bitwise and. Okay, so we will cover these couple interesting topic operators like bitwise and, bitwise or, bitwise exclusive or, bitwise complement, and shift left, shift right, this idea. Let's take a look of these details. Actually, for first four operators, the idea is not so complicated, not so hard to understand. Let's take a look for not, these bit operators. The not means we try to do a reverse. So if we got zero, it will change it to one. One will change it to zero. That's it. That's it. Very simple, right? So if we talk about other stuff, it's still not so difficult, a little bit complicated, but it's not so difficult. The end is the bitwise end. So if you try to do a zero and zero, you got zero. One and one will get one. But if you want to do one zero, it was zero. So on either way, like if you got one zero, it's always zero. So you can only get one if both this number are one. Otherwise, you got zero. For OR, it's different. The OR means you always got one, except both number are zero, and you got zero. Otherwise, you got one. So this is the difference between the AND and OR. Okay. So for the AND one, you have to get two one, then you got one. Otherwise, everything else is zero. And for the OR one, you got zero if both the number is zero. Otherwise, you got one. XOR inclusive OR, this is very different. This is very different. This will try to compare two value. If the two value is the same, it will return zero. Otherwise, return one. So if you take a look of these details, if I got one and one, we will get zero. Zero and zero will get zero. But if we have a zero and one, we will get one. Zero and one will get one. So if the two number they are equal, it becomes zero. If the two number they are not equal, different, it will return one. So this is the difference. Let's do some like a quick math stuff for this one. So if we want to do a not, it's easy. One becomes zero, zero become one becomes zero, zero become one. So that's it. This is how you do this computation. So if you have a long sequence of your like a number, like you have 32-bit number, it's still not hard to compute this, right? You just do a reverse way. The end one, if both are one, then it's one. Otherwise, it's zero. This is for end, bitwise end. For OR, only these two zero get zero. Otherwise, it's keep one. Okay, so this is different. For the exclusive of or this is a different. This will compare two value. If they are the same, keep zero. Same, zero. Same, zero. Not same, one. Not same, one. So this is how you compute these operators. Okay, so good, get the idea, right? Okay, so let's take a look of other operators called left shift and right shift. What's a left shift and right shift? Assume you have a whole bunch of numbers. Let's say you have a number 4. And I want to do 4 left shift 2. What does it actually do? If you already jump into the binary world, jump into your computer world, then you will know the 4 is actually equal to 0, 1, 0, 0, right? So shift 2 means I want to shift this bit by 2 bits. So what this means? It will become, if we do shift 2, it will become 0, 1, 0, 0 plus 2, 0 at the end. So what the number is now? It's actually 16. So this is 16, right? So actually, if you do the shift, you just put how many zero at the end as a binary. So if we try to do the three, let's say, okay, I have another number, is seven. Seven shift three. Seven means 0, 1, 1, 1. Shift by three, you will get 0, 1, 1, 1, 0, 0, 0. And actually, what's the number of this? 56. How can I compute this so fast? Because if you remember what's this represent, each zero here is about the power of exponential of 2, right? So if you understand this part, this shifting is actually can give you a multiplication. So if you shift to 2, it's equal to 4 times 2 power of 2. And it's equal to 7 times 2 power of 3. So how many bits you shift actually times the exponentials, the power of the number n power of 2, right? So this is how you actually compute. So shift can give you a really easy way to do like a quick multiplication, because you know the traditional multiplication, you need to have a whole bunch of number, you try to times each bit to other bit together. But if you do in a binary way, in a big way, you just shift it. That's it. So you want to do this kind of product or times, it will be easier to manage to compute. So this is a good way to go. So if you can understand the left shift right, you probably can get the idea. If we try to do left shift k, then actually this number shift k will become number times 2 to k. This is the conclusion. In other way, if we want to do the right one, you will get the similar one. So how to do a right one? If we have let's say a 7, which is equal to uh, 0, 1, 1, 1, and we do 2, what it actually do? It will remove these 2 bit. Remove 2 bit. You want to do a right shift of 2 bit. So it will become 0, 1. And you know 0, 1 is what? Is 1. So what is actually do? It's actually equal to, if you have a number n shifted by k, it will be an integer division. It's an integer division and divide by 2k. So in this case, 7 divided by 2, which is 4. So 7 divided by 4, integer division, we get rid of the decimal point, right? So it's equal to 1. So match, right? So let's try another example. So if we have another example, let's say 10. 10 equal to, in this case, 10 is 1, 0, 1, 0. So if we shift, let's say 3, what we got? 10 shift 3, we got 3 number L. So it will equal to 0, 0, 0, 1, right? So actually, this is right. 10 divided by 2 to 3 equal to A. So 10 divided by A equal to 1, right? So if we change the 3 to 2, what happens? It will get 1, 0 because we get rid of these 2 bits. And 1, 0 equals to 2, right? Base 2. So this is base 10. This is base 2. Base 2. So in this case, okay, so 10 divided by 2, 2, which is 4, equal to 2, blah, 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 blah. So it's equal to 2. So actually, this is an integer division. It's not no decimal point, but it's an integer division. Okay, so if you got this idea, you know what's the difference between left shift and right shift. Actually, it's the bitwise operators. They work really perfect in this like binary world. This is why we cover this stuff here. Joe, I have a questions. I'm wondering, so far you talk about a division, but if it's a negative division, How can I do? If a negative one, the bits, how bits got update when we do the division? Can you tell me? This is good questions. Actually, yes. If we want to do everything here, it's a shift operators, and the number is a negative number. What's this actually do to handle this negative number? Let's take a look of the details. So when we do the shift operators to the right one, for left one, there's no difference because you use negative one, you just always put, you can always still put zero to do the negative one. However, for the right one, it's a little different because when you do the right one, you need to think about it's an unsigned number or signed number. For example, if it's an unsigned number, of course, we can always put zero, but before, right? So let's say we have 7, 7 equal to uh, 111, and we have a whole bunch of zero here. When we do the onside one, we can just try to do a shift, for example, shift to 2. We just get rid of these 2, and we got 0, 0, 0, 0, 0, 1, 0, 0, 1, and then we put just put 20 before it because we get rid of 2-bit, we also need to fit in 2-bit. This is for onside. So actually, if it's positive number, there's no issue. However, if it's a negative number, if it's a negative number, let's say if you have a number like 1, 1, 1, 1, 1, 1, 1, and when you do a negative number, if you do shift to 2, then you get rid of this 2, put 0, it will give you some trouble because you change the negative number to a positive number by a division. This does not make sense, right? So when you do a side shiftment, if the number you have is a side integer or side number, what it actually do? It's the same as what we covered in previous lecture. It will use your most significant bit. Most significant bit, it will use a most significant bit as the base. If the most significant is 1, it will copy 1 here. It will put 2 1 here and get rid of this. Okay, so this is how you like represent a negative number. So in summary, what you actually do, if if it's onside integer, if it's onside, if this is onside 1, you just always give 0. But if it's side one, you try to choose the most significant bit. The most significant bit, if it's negative number, is 1. If it's positive number, is 0. You just use the most significant bit as a base. Try to fill in the same bit before it when you do this shiftment. So in this case, you can take care of both positive number or negative number. You can take care of both onside integer and side integer. Okay. So let's take a look of the comparison between the Java and C, uh, because it might be a little bit different if you don't really understand C, the onside and side one. So let's give you a picture of this. For C languages, we have a side and onside type. So you can say this integer is a side integer or this integer is onside integer. You can define it and depends on how you define it, it can give you a different range of numbers. Java only have signed integer, so you don't need to worry about onside one. Okay, so this is a big difference. For the shift operators, because there's a side one and onside one, so you need to take care of how you fit into some like a most significant bit. So it will depends on the different type. If it's onside one, it will do a logic shiftment. If it's side one, it will do an arithmetic shipment. So there's a different way to do this like a fill in, a bit fill in. For Java, you don't need to worry because it's just side one, always a side one. And the operator will be a little bit different uh, in the side one because if you want to do a logic shift, you can do in this way. So you can choose, in this way. Otherwise, you just use this one. So original one, the original one is just the regular one because it's side one, so it's always use arithmetic shift one. However, if you want to do a logic one, you can try these different operators. So in Java, there's 2 different operators for this. But in C, because we have side and side, so we don't need 2 operators. They will just follow your type to make a decision how to do this shiftment. Okay. So this is for today's. We talk about the bit operators in this class. We talk about the bitwise and bitwise or bitwise complement, bitwise exclusive or, and we also talk about shiftment, left shift and right shift. They are really useful in C, especially when you want to do multiplication or division in a really quick way. They can speed 100% speed up your computation. So keep in mind that some like good techniques you can like use here to for your future projects. Okay, so hope you enjoyed today's lecture. See you next time. The bit operators is cool.